Hello everyone. Functions again. Welcome back, and we are going into more functions. This time we are talking about recursion, and as I have, I guess, I already warned you, it's going to be a slightly difficult video than normal because obviously it's recursion. So it's kind of hard to grasp, but I'll try to be as easy as possible. So what is recursion? Recursion is a property of function to be able to call itself. Duh. Okay, as you saw in that picture. um, so we can use it to get factorial of a number. These are just easy example. As you get more into programming, you'll find a lot more use to recursion. Sorting for one. Generate Fibonacci sequence. If you don't know what Fibonacci sequence is that sequence right there. 1 1 2 3 5 8 13 21 is just basically the next number is going to be the addition of previous two numbers. That's Fibonacci sequence. And factorial is if you say you want a factorial of some number n, then it is basically the multiplication of all natural numbers before n multiplied together. So if you want to get factorial of 5, it's 1 times 2 times 3 times 4 times 5 equals to 120. All right, so let's see how to write recursive function. Create a function, make a call to itself, and make sure you have something called the exit case. This is very important because you don't want to get stuck in an infinite loop. So I'm going to show you a couple of code examples. One is going to be factorial code. It's kind of simple. Fibonacci is going to be slightly difficult. Both are difficult on its own respect, but Fibonacci is slightly more complicated because it involves double recursion in the code that I have. So let me first show you the code right here. Okay, so here is a factorial program that I have, and in this program I just have a main function. It calls for a function called factorial to print out the factorial of user input number is stored in X, and that number, this is basically a recursion right here, recursive function. You can see what it does is it comes here and says if num is less than or equals to 1, it will return 1 because 0 factorial is also considered to be 1, and any other factorial is 1. Also factorial of 1 is 1. If that is not the case, what it's going to do is it's going to call itself, but this time it's going to subtract that number that was originally passed into it by 1. And so there is num. We multiply, let's say if 5 is passed, 5 will be multiplied to the factorial of 4. Basically that's what it is, right? 5 factorial is 4 factorials times 5, 4 factorial is 3 factorials times 4. So that's basically the idea. So factorial of 5 is 5 times factorial of 5 minus 1, you see, and recursively it computes, and what it does is it returns one value. When it gets to 1, it returns 1, and then from there it computes back to give us the whole output. I'm going to show you how in the presentation. And here is a Fibonacci sequence that most people like to explain about when talking about recursion. I have seen a lot of people doing a really bad job explaining this, but I'll try to do my best. So here we have in Fibonacci sequence we basically have something called seed. Seed would be 1 and 1. Some people like to use 1 and 0, but it's all up to you. It doesn't really matter, I guess. But here what it does is if you want to print out 5 Fibonacci numbers in a row starting from 1, then here it will ask you how many Fibonacci would you like to print. If I say 5, then it's going to take in 5 and send it to it's going to do 5 times to compute that 5 sequence of numbers. So it will just go here, and recursively it's going to call each other and going to give the answer. and I'm going to show you how in again the presentation. This here we have double recursion, that's why it's kind of tough. Here I have another Fibonacci program. It will just basically ask you what would be the maximum number of maximum number in Fibonacci sequence, and it will just stop right there. Okay, so this is not very common, but I'm just going to put this in my resource in my website DigitalStage.org. Go there and grab it if you want it. Okay, so let me explain it on presentation. Back. Okay, let's go to Factorial. In Factorial we have this little function, recursive function. That's where I'm going to start at. So as you can see in Factorial so blah blah basically, so that when with n equals to 5 it's translated into that originally. So 5 is being passed, and it will check if 5 is less than or equals to 1, and it will go to else, so it will return factorial of 4 times 5, right? So it's this factorial of 4 is calling the function factorial again, so it's going to spawn another instance of factorial, and this time it's passing 4, and this time it's a factorial of 3 times 4 is factorial of 4. So since there is 3, it's calling another factorial function. This time it's passing 3, right? So since 3 is also not less than or equals to 1, it will again have to return factorial of 2 and multiply that with 3. So it will go again send 2, another factorial function. Now it's asking for factorial of 1 times 2, so factorial of 1 when it goes here, now it can return 1 this time. Finally there is some number to return instead of calling this function over and over again. Kind of frustrating, I know, but there with the recursively it have called itself, and at some point it have ended. That is the exit case here. Okay, so now it will return 1 to this little factorial of 1 that is here, right? So this time what it will return 1 from here, and so now this return statement will be executed, and it will return 1 times 2, which is 2, to this little factorial guy right here. So 2 times 3 is going to be return 2 times 3 is going to be 6. So from this return it's going to return 6 to this guy, and this guy is going to multiply 6 times 4, 24, and it's going to return 24 from this part right here to this guy, right? And 24 times 5 is the return value of this guy, and boom, there we go, 120. Magic, right? Really fun. I spent quite a time making this flow right here, but I hope you can visualize what's happening with the recursion. It's very good practice to make chart like this in your paper when you're doing recursive functions. Otherwise you are going to mess up your own head. Alright, now let me show you Fibonacci. It's going to be extra tougher than that. So we have this Fibonacci function just like that, n equals to 5. It's going to be something like that. That's correct? Yes, of course it is. Okay, so x if is 5 less than or equals to 2? No, so it's going to return Fibonacci of 4 plus Fibonacci of 3. So guess what, 2 Fibonacci functions is spawned just like that. You see, 2 Fibonacci functions called. So Fibonacci 4 is going to call Fibonacci 3 plus Fibonacci 2, and there it goes. Fibonacci 3 is right there, Fibonacci 2. Okay, and from down here Fibonacci 1 and Fibonacci 2. those two are called. Now as you can see, it got into the exit stage right here, because whatever value is sent here, it's less or equal this condition satisfied. So now it's going to not going to call any other function, but it's going to return an actual value from here. So from both of these, wherever these things were called from, it's going, you can see these three red arrows here, it's going to return to those red arrows, just like that. Return 1, return 1, and return 1, right? Now from there, since in this Fibonacci 3 box right here, it already have two values. Here's 1 and here is 1. It's got 1 plus 1, so it's going to return 2 from here to that guy, right? And since it already have 1 returned from here, so 2 plus 1 is going to be, guess what, 3. So we have 3 numbers from Fibonacci sequence, 1 1 2 3, right? And that is going to get returned to that guy. It's pretty interesting. And that 1 plus 1 2 is going to get returned to this guy. So 3 plus 2, guess what, it returns 5, and fifth Fibonacci number is 5. Amazing. That's the recursion idea, and you'll be using it to sort, maybe even search, and a lot of things in the future, not just Fibonacci sequence. But it's just practice this a bit, write it in a piece of paper, and if you don't understand this video quite clearly, let me know. I'll take that as a feedback. I'll try to make it much more simpler and try to explain it better. But yep, there is the basic C++ done. Next I'm going to intermediate C++, talk to you about more maybe compound data structures, and we'll talk about classes, and you'll get into more object-oriented programming. You know what things, terms like inheritance, polymorphism, and whatnot. It's going to get really interesting. And next video coming very soon. Just go to digitalstage.org for all the resource, the files, and everything. And please leave a comment. Every comment that you make is going to be very constructive for me. Thank you for watching. Hope you understood what I told you today. Have fun. Bye bye.